Dear students, today we are going to learn how electric bulbs light up and how electric fuse saves our devices. In other words, today we are going to learn how electric current produces heating effect. So let us continue with the lesson electricity, which is chapter number 12, and today we will be learning heating effect of electric current and its applications. This is part number 6 of the lesson. In the last session we had studied about series combination, parallel combination, and we had also solved few numericals from the chapter. And as I said, today we will be learning about heating effect of electric current. Students, if the electric circuit is purely resistive, that is, a configuration of resistors only connected to a battery, the source energy continually gets dissipated entirely in the form of heat. So, this energy supplied by the source, it gets converted to heat. How? Let us see. So, why does electric current produces heating effect? Students, when we apply a potential difference across two ends of wire, current of electrons is set up in the circuit. Now, during the motion of electrons, they collide with each other and also to the ions. And when they collide with the ions, they lose their kinetic energy. This loss in kinetic energy appears as a heat and the temperature of wire rises up. Thus, due to the resistance offered by the circuit, electrons collide with the atoms or ions and also with each other. That's the reason of resistance in fact. And due to this collision, there is loss of kinetic energy of electrons, and then this loss of kinetic energy results in increase in the temperature of the substance. So it appears in the form of heat. Let us move on to the next point. So this is known as heating effect of electric current. This effect is utilized in devices such as electric heater, electric iron, electric bulbs, and there are a lot of devices that uses this effect of electric current. Let us see the next point. Now we have to derive the relation for this heating effect. So we have to consider a current I flowing through the resistor of resistance R, and the potential difference we will consider it as V as shown in the figure. So this is a figure. So here there is a cell, then there is a plug key, then there is a resistance, and there is potential, what we call it is a voltmeter that is connected across the resistor. Also there is here ammeter which will measure the current. The power input to the circuit by the source is given by P is equal to V into Q upon T. Now what is V? We all know it is potential difference, and Q is a charge flowing through the circuit, and T is the time in which it is flowing. So if we want to calculate this power, what we have to do is multiply Q upon T with the potential difference. So what is Q upon T? Q upon T is nothing but rate of change of flow of charges with respect to time. So this is nothing but a current. So you can also say power is equal to voltage into current. So V into I can also be written. We are going to see this in the coming topic also. So what is P? P is equal to VQ upon T, and this is equal to V into I. Well, the energy supplied to the circuit by the source in time t is equal to P into T, but P is V into I. So altogether we get the energy supplied as V into I into T, that is potential difference into current into time. This energy is nothing but a heat dissipated in the circuit. So, this energy gets dissipated in the resistor as heat. Thus, for a steady current I, the amount of heat H produced in time t will be given by H is equal to V into I into T, which we have already used. This energy is nothing but heat energy. So, if someone asks you to calculate heat, we should at least have three terms V, I and T. Okay, but using Ohm's law, we can simplify this formula. How? Let us see. So, applying Ohm's law to the above relation that we have just now used, it becomes I square RT. How that happened? How VIT become I square RT? Students, if H is equal to V into IT, then as per Ohm's law, V is nothing but I into R. So if in place of V I put I into R, then the entire relation becomes I into R into I into T. So applying Ohm's law to the above relation that we have just now used, it becomes I square RT. How that happened? How VIT become I square RT? Students, if H is equal to V into IT, then as per Ohm's law, V is nothing but I into R. So if in place of V I put I into R, then the entire relation becomes I into R into I into T. So I into I becomes I square and then there is RT. So this can be written as I square RT. There is another method also. We can write it this equation in another form also. However, first let us know what we call this relation. This relation is called as Joule's law of heating. The law implies that heat produced in the resistor is directly proportional to the square of the current. So square of the current, that is I. Then it is directly proportional to resistance of the given circuit and directly proportional to time for which current is flowing through the resistor. So the heat produced depends on these three parameters. Which one? Square of current, then resistance of the circuit and the time for which current is flowing. So now it's time to see the practical applications of heating effect of electric current. Electric bulbs is one of the widely used applications of heating effect of electric current. What happens with electric bulb is when current flows through this wire, it produces a heat, energy is dissipated in the form of heat and the temperature rises so much that the wire connected between two poles start glowing up. Now remember, for such type of devices, the resistance of the wire should be high. Also, the melting point of the wire should be high so that it doesn't melt. So, such wire, if you see, you can use tungsten, has all the properties of which we need in electric bulb. So whatever properties that we need in electric bulb wire or filament, those properties are already present in tungsten material. Tungsten has very high melting point, so it produces heating effect, it produces light because of heating effect, but it doesn't melt. There are various other examples of heating effect of electric current. There is electric laundry iron, electric toaster, electric oven, then electric kettle, electric heater. Lot of devices are there which use heating effect of electric current. As we all know, just now we saw that electric heating is also used to produce light in an electric bulb. What happens in electric bulb? Let us revise. Here the filament must retain as much amount of heat generated as much as possible so that it gets very hot and emits light. Now it must not melt at such a high temperature. A strong metal with high melting point like tungsten, which has a melting point of 3380 degrees Celsius, is used to make a bulb filaments. Another common use or common application of Joule's heating is the fuse used in electric circuits. So what happens in electric fuse? When a large amount of current, which is greater than the rating, if it flows through this device, the wire inside the fuse breaks down due to the melting point, due to its low melting point. Okay, so suddenly lights are turned off because of this breakage. Now, students, how does it help by breaking the circuit? Now, for that, we must understand that the devices that we use have certain current ratings. If above that we supply electric current to it, that may damage the electrical devices. So, what do? We connect this electric fuse in a circuit in series order, which we have already seen. In series order, we connect it with the inner circuits. Now, when we connect it in series, the wire which is used in electric fuse, because of its low melting point, if the current above the prescribed rating flows through the wire because of its melting point, suddenly it breaks down if high amount of current is flowing through it. And since it breaks down, current does not flow inside the circuit and inside the devices that we are using in our home. And this saves the devices, because if such a large amount of current flows through the device might get damaged. So to save these devices, electric fuse, what does it do? It breaks itself. The wire breaks and saves the device inside it. This is like you can compare this with the soldiers on the border of the country. This soldier, sometimes they have to die in the battlefield to save the people of the country. So this electric fuse is like soldier for our household devices. He dies or he breaks himself to save the inner devices. Let us revise. It protects the circuit and appliances by stopping the flow of any unduly high electric current. The fuse is placed in series with the device. Very important. It is placed in series with the device so that all the current, first it should go through the fuse. It consists of piece of wire made of metal or an alloy with the appropriate melting point. For example, it can be aluminium, copper, iron or lead. Mostly we use copper or aluminium wire. If a current larger than the specified values flows through the circuit, then the temperature of the fuse wire increases. And this, what it will do? It will break the circuit. So this melts the fuse wire and breaks the circuit. Well, that was heating effect of electric current and what are the applications of heating effect that we studied. Now it's time to get on to the last topic of the chapter, which is electric power. So what is electric power? The equation that we have already used, H is equal to I square RT, gives the rate at which electric energy is dissipated or consumed in an electric circuit. This is also termed as electric power. And how do we represent it in mathematical form? It is given by P is equal to V into I, which we already know. But this can also be written using Ohm's law as P is equal to I square R. How did we get this relation? We used Ohm's law. V is equal to IR. So if in place of V I put IR, then IR into I will become I square R. Also we can write it in the form V square upon R. And how do we do it? Again, here instead of I can write V upon R using same Ohm's law, and if I use here V upon R, then V upon R into V will give me V square upon R. So these are the relations that we use to find out electric power. Now let us see the unit of power. The SI unit of electric power is watt. It is a power consumed by device that carries 1 ampere of current when operated at a potential difference of 1 volt. So what is 1 watt? 1 watt is equal to 1 volt into 1 ampere. Well students, that was all for today. Now let us see assignment. So you can try to answer what determines the rate at which energy is delivered by the current. I repeat the question. What determines the rate at which energy is delivered by the current? The second question is, why is tungsten used almost exclusively for the filament of electric lamps? Third question is, what is electric power? And the last is, explain any one example of heating effect of electric current. So these are the 4 questions that you have to try out at home. Okay. Well, if you have any doubts in this session, you can ask me anytime. You can put your comments in the comment box. Okay students, so that was all for today. See you in the next session. Until then, take care. Bye bye.